So the title of this talk is Building Blazing Fast Backends with Elixir. If you're meant to go to a different talk, this is not the room for that one. This is the room for this one. Okay, I'm Ari. You can feel free to tweet at me at a user at any time. Who am I? Let's see. I'm an author. I've done most of my stuff in software. I was a stand-up comedian for about 8 years professionally. Now I do software, so tells you how that went. I'm also my parents' IT person, so if anything goes wrong with my parents' phones, I'm the one that's responsible for fixing it. I also am a dog owner, and this is the only time that she shows up in this talk, but she's fantastic. Her name is Ginger. I got her on a TV show. Okay, so enough of that. This talk is hands-on. It's a tutorial-based talk, so feel free to jump on your computer if you have it. If you don't, this talk is recorded, so you can watch it later when you do have your computer with you. What I want out of this talk is for you to be able to come out of this talk being able to build backends with Elixir. I also really find Elixir and Erlang to be really fun, so that I hope to help convey that to you as well. Before I actually start in on the talk and the typing and all that fun stuff, raise your hand if you've used Elixir in the past. Raise your hand if you've used Erlang in the past. Okay, raise your hand if you've used a functional language. Okay, cool. I guess without further ado, let's get to it. So if you are going to follow along in this talk, right now is a really good time to open up your web browser and go to elixirlang.org and install Elixir if you don't have Elixir. If you do have Elixir, ignore that and follow along. So why Elixir? Well, I think one of the reasons why you need to look at Elixir is it's super fun and it's super awesome language, but Elixir is the language that compiles down to the Erlang VM. So really, when you ask the question why Elixir, other than the fact that it's a really nicely typed, it's a really nice language to work in, I think you need to ask the question why Erlang, and that here in Sweden is like a really awesome place to ask that question because Elixir or Erlang was built here in Sweden. Erlang itself is scalable, it's fault tolerant. We've all heard these words before, right? It's a functional language. Elixir itself is built to be extensible. Erlang itself is built also to be to keep a telecom company up. So it's been in production for decades. So it seems like there's a really good stability story there. And it's hot reload friendly, and garbage collection in Elixir, or specifically in Erlang, is super fast because everything itself is a process. You don't get like those garbage collection hiccups that you get in other languages. Everything, as I just mentioned, everything in Erlang is its own process. So when you want to communicate between processes, you send messages back between them. There's no shared memory, you don't have any locks, there's no mutex, things like that. And when I say processes in Elixir, I'm not talking about system processes, which are heavy. When you do like a fork in C and then you copy all the memory space over to another one, that's a heavy process. When I talk about processes in Elixir or in Erlang, they're really lightweight. So you can create 10,000 really quick and kill 10,000 really quick. On this machine, which is a 2011 machine, that's pretty impressive how fast it can go. It's fault tolerant. Actually, the OTP library implements. Not only does it implement supervisors for your local machine, but the distribution, the distributability. That's not a word, is it? Distributability. Okay. The distribution story is cool too. You can create a process on this machine and on another machine as long as the network is set up. You can communicate between the two, which is really, I think, really neat. But who watches those watchers? Anyway, okay. Elixir is a functional language. I really like functional languages. I feel like they create. First, I have a ton of fun building in Elixir, or sorry, building in. I do have a ton of fun building in Elixir, but also in functional languages, I think that they specifically help us focus on small composable functions that are easily testable. They're also it's also creates like really maintainable code and really testable code, so you can ensure that the code that you're pushing to production is um, is performant and performs the way that you expect it to. And it's really super easy to slide in and out a new version of a function versus necessarily having to rebuild an entire backend. The language itself in Elixir is extensible. It's built with that in mind. And as I said before, the stability story in Erlang, it's been in production for decades. So it's built for 9 nines, which equates to like 23 minutes of downtime a year. It's pretty impressive. Erlang allows us to stop, start, load, update code without actually restarting the entire application, which is cool. Then you don't have to deal with when you're pushing production updates to your code, you don't have to deal with doing like that soft reload with your load balancers in front. I also think it's really fun, and I hope to communicate that too when we start writing some Elixir code. Also, another really cool thing about Elixir is that there is a ton of tooling. We have built-in compilers, a build tool, interpreters. There's hot reloading, observers, as we'll see, things like that. The mixed build tool itself is built in. You don't need to install like rake or make or another one of those. And testing is built kind of just right in. You guys convinced? That was so not enthusiastic. Convinced? All right. Okay, so let's move on. Let's talk about Elixir, the language. I'm not going to do too much cover of Elixir, the language itself, because there's a lot of great documentation online, but I am going to talk about some of the cool things. If your computer is open and you've installed Elixir, you have this sweet little tool called IEX. IEX stands for Interactive Elixir. Can we all see that? How about that? Okay. This interactive Elixir allows us to operate with Elixir in the command line, just like we're writing it in a file. We can also, in IEX, oh, I think I just froze my computer. Oh, there we go. In IEX, we also have access to the H command, which stands for help. Elixir's documentation is fantastic. This is one of my favorite parts about the language. It's nobody's favorite part about the language, right? But I spent the last 7 years writing books, so who am I to talk? In IEX, we can see that we have helpers like like the help command. That's what comes up when you're curious about how a function works. That's awesome, right? Not only do you get examples, but you also get a description of how it works, and what inputs it expects and what outputs it expects. And that will come in really handy. And we can add our own help documentation, as we'll see when we get to writing our own Elixir code. If you are writing your code in a file, you can, in IEX, load and reload and compile those files. So as we're updating, as we'll see in a few minutes, as we're updating our code, we'll reload in IEX, and we'll be able to manipulate the new code and not worry about having to kill and start our interpreter over again. So Elixir handles types, just like a lot of other languages do. It has numbers, floats, booleans, atoms, lists, tuples, other functions, stuff like that. We get these really neat guards in Elixir where we can, in our functions, we can use a guard like is a number to use pattern matching in our code. So if you, let's say that you have like a hello function, and that hello function can take either a string, or it can take a string as a list of chars, characters, or it can take a number, so it says hello number a number of times. You can use these guards to set up pattern matching based on what the input of your function is. I think that's really neat. This is what it looks like to define an Elixir function. You have def and defp. Def is a public function for a module, and defp is a private function, which means only the module that contains it can actually call it. Elixir documentation, as I said, is really, really awesome. When we write our code, we'll use annotations, these annotations. Like, for instance, this annotation is the doc annotation, which allows us to write not only a description of the function we're running, inputs that it expects, but also examples. And one thing that's super neat about this is that there's a way to turn your documentation examples, this right here, into a test. So you don't have to write a separate line of testing code as long as you write your documentation. So not only is, like, you know how they say like testing is like the documentation of your code? That's why you write tests. Well, Elixir takes that to the next level, and your documentation literally can be turned into a test. No response from that? That one, I expected that one at least. Documentation is really great for communication across developers and teams, especially for software. If you're developing open source software, it's especially important. Another language feature that I really like about Elixir, raise your hand if you don't know what piping is in Unix. Okay, so piping in Unix is taking the output of a command and passing it as the input of another command. You can do that in Erlang using the pipe operator. So for instance, let's say that we want to turn this into a list of capital uppercase tokens. We want to turn whatever string we pass in as uppercase tokens. What we can do is we can take the output of the previous command, which is just a string here, and we can pipe that using the pipe operator. And we could say we want to capitalize all that. That's cool. But what if we want to do something else with that? We can also do that. String.split. Now we have, it's real, that what I'm typing here, it's really clear what I'm trying to do, right? Just read this line right here, and it's super easy. I think that's super neat, and we'll use it in code in a few minutes. Also, another really awesome thing, just like Erlang, Elixir has pattern matching, so you can take, as I mentioned before, we can do these things with guards. We can also write our functions so that we're matching based on the output or the input of a call to that function. So in this case, hello might just take an OK module, and we might say, oh, cool, that is OK. But notice all the definitions of this function are all the same. They're all the same. It's all hello, but this is based on whatever we're passing in. If you have an underscore, that's a hint to the compiler that we don't care what's going on in there. That's a catch-all for this hello function if we pass something other than OK or error. Yeah, I agree. It's awesome. Okay. So let's jump to a project. If you're following along on your computer, see where I am. If you're following along with your computer, let's use the mix tool. We'll use the mix tool to create ourselves an application that we'll call, let's say, first app. And we'll cd into that directory. And we'll run mix test just to make sure it works. Hooray, it works. Okay, so the first things first, let's go ahead and open this code up in a text editor. And the code that it generates, there's two files that we'll focus on. The any file that's in the lib directory is a library code for the application that we're writing. Everything with an EX file is compiled into our Elixir application. Anything with an EXS file is it's not compiled into the application. It's more it's like a system file, like the mix EXS file, which we'll look at in just a second. Okay, so because we'll be writing some code in here, let's go ahead and start up our interactive Elixir. Whoa, my bad. Let's go ahead and start up our interactive Elixir command line, and we'll also say that we want to start our application as a mix application. The -s just says, hey, start this thing, or run this command. So if we wanted to actually run our application, we could say run, but we're not. We'll just run mix, and that just tells IEX that we want to load up all the mix files that are in our current directory. Okay, so we could build a web server if we wanted to. I think that's useless. None of us are really going to go and start building a web server. But if you want to see how it works, we could do it using something like GenTCP, where we can listen on some socket or on some port. Oops. We could listen on some port, and then we could listen for some messages. And then we could do whatever we want with that message. For instance, we could telnet into there, and that would provide us a TCP server. If you wanted to build a web server, I'm not actually going to do that. If you wanted to build a web server, then we would just have to listen for HTTP, the web request headers, HTTP 1.0, what method it is, if we have any, accept type. We have all the headers that we want to listen to. But like I said, I think that's kind of useless. None of us are really going to do that unless we're trying to make something really super fast, in which case I'd just say drop down to C and write it in there. There's a lot. But anyway, you could if you wanted to. But instead of doing that, let's go ahead and install a dependency that provides us a web server. So I mentioned before we have this EXS file, this mix.ex file. This mix.ex file tells our application when it's compiling some compile time things, and it also allows us to define applications that our application depends on as dependent applications. We can also define dependencies here. So we'll use a couple dependencies. The dependency, right, just talked about that. The dependencies are defined in the deps function block. We're going to use a dependency called Cowboy. Cowboy uses a dependency called Ranch, and Ranch is a HTTP acceptor which every single request that comes in, instead of being like Node, where Node will respond with the request and block. So when a new request comes in, that new request has to wait for the previous request. What Ranch does is it spawns off another process and uses that process to handle the web request, and allows the main process to be non-blocking, which is why it's super fast. So we'll use Cowboy, and we'll also use a library called Plug, and Plug allows us to, in a really nice, convenient way, handle and define how we want requests to be handled. So if you want to go and look and find the latest versions of these, we'll use the mix tool again. Man, it's so handy how this thing comes in handy, right? Let's go ahead and look at what the latest version of Cowboy is. It's 2.5. Go ahead and grab that and update our deps function. And we're also going to use plug, Cowboy plug and plug. It might be plug Cowboy. And while we're at it, let's go ahead and add two extra dependencies. We'll use earmark and xdoc, and we'll see why in just a minute. And I think I have all those here. Great. Okay. Mix just wants to get involved in everything, right? Just use it again and say, let's go ahead and fetch those dependencies. We can also use mix to compile those dependencies, either by using mix compile or deps compile, and that will compile our dependencies. Let's go ahead and compile our application while we're in the background. So in order for us to use Cowboy and plug, we're going to have to tell our application that it's dependent upon two other, when I say application, I mean processes. Our application is going to be dependent on plug and Cowboy. The way that we do that is go back to the mix.exs file and add it to our applications. These applications right here define apps that, like I said, that our application is dependent on. So we're going to be dependent on Cowboy and plug. Great. Okay, so that was fun. Hooray. That was so easy. I didn't do anything and got a response that time. Okay, so let's go ahead and actually build a web handler so we can see how that works. Let's open up in our first application our library file, our first app library file. And let's say that we want to use the plug router. This is a behavior. This in Elixir, using the use keyword, implements behavior for this application. The behavior that we're using is the plug router behavior. We're also going to use a plug called match, and this does what you expect it does. It matches requests when they come in. So if we have a GET request, we'll be able to define that we want how we want that GET request to be responded to, or a POST request, or a head, or a query, etc. And then we'll use the dispatch plug, and the dispatch plug is the thing that says, oh, I'm going to call out to this function and run that function to handle this web request. The next thing that we need to do is we need to create a start function. Router. Let's go ahead. We'll just erase this guy. And we're going to use the plug adapters.cowboy HTTP to execute our router, and we'll say that we want it to be, what do we call this, first app? And we want it to be on port, let's say 4000. What do you think? That's a reasonable port. So before we can actually run it, we have to add a route. And to prove that, I will say, let's go ahead and try to start our application without having a route in there. Now, we get a compile error, and that's because there's no routes defined in the module that we just started writing. That's awesome. This means we're not going to deploy a broken router into production at all because we can't compile our application. Wow, that one's cool. That's way cooler than JavaScript, in my opinion. Don't tell anyone. Okay, I wrote a bunch of JavaScript books, so this is being recorded, isn't it? All right, so let's write a catch-all route. This catch-all route will catch all requests that are not previously handled. When we're using plug, we get access to this object, this weird object called connection, just C-O-N-N. To be totally honest, I hate this convention, but I would much rather we pass that in. But we get that as a local variable in any requests that we're writing, thanks to the plug module. So here we're just going to send a response of 200, and we'll say, I don't know, hello world, because that's what you do, right? Hello world, or foobar. Okay. Okay, so now let's go ahead and try to run our application. What we can do is, the first thing that we're going to do is we're going to call first app, and we're going to call start link. And that start link function here tells Cowboy, the library that I described before that uses Ranch, that we want to start this specific module, first app, as our router. We can also, because it's this app, we can also use the language underscore module, all caps like that. That just says this. That just means this module. But to be explicit, we'll keep it as first app. All right, so let's start this. Worked. I don't know why I tempt the demo gods every single time I give it a talk, but it's a really bad idea. And let's go and hit port 4000 and see if it has my silly string. Hey, look at that. It worked. Okay, cool. So let's say that we don't really like hello world or foobar question mark or something. Let's change that. If we come back here and we refresh our web server, notice that that language doesn't change. We can, because we're using IEX, we can hot reload that, and we'll just recompile that module called first app and hit that again in updates. I didn't recompile anything. I didn't do anything other than tell IEX that I wanted it to auto recompile. That's fancy. Way fancier than some other languages. I really got to stop digging on other languages. I'm kind of a language geek. Okay, so we added a route and we started up our application. Hooray! Remember before I mentioned documentation is one of my favorite parts about Elixir? Well, let's, I told you I'd get back to it. So let's go ahead and generate some documentation based upon the code that we actually have, based on the code and some PID here. Based on the documentation that we have in our code. The way we can do that is by jumping out of IEX and type mix docs. And this is where earmark and X docs come in handy. And auto-generated for us are really nice looking docs. So as we're writing our functions and we're writing our modules, we can communicate exactly what it is that we're trying to do with every single function that we're trying to write. And one of the cool things about having earmark and xdocs as dependencies for all of our modules is the fact that you can depend on every single open source piece of software, every single library written in Elixir, the documentation will look like this. That is awesome, because you no longer have to say, oh, how do I get to this thing? How do I get to that? Every single piece of documentation looks identical. Well, except for the contents, but the layout looks identical. And you can change modes and stuff. I think it's really neat. Okay. Hey, that one was deserving. All right. So let's talk about supervisors. Supervisors in Erlang are things that watch other things and respond to events that happen, or respond to things happening to those things that the things are watching. I tried to get another thing in there, but I couldn't. I tried. I'm sorry. All right, so let's go ahead and create a supervisor. First things first, let's move our first app file into a directory, and we'll call this first app file. Instead of first app, we'll call this router. This is really just, you don't have to do that if you don't want to. I do that because it's a router. It's no longer an application file. So let's go ahead and create a new, again, if you're following along, let's go ahead and create a new file. And we'll create a module that we'll call first app. And let's also rename this our router module to first app router, because that's what it is. It's a router. And we are going to create a supervisor. A supervisor requires, in order for our supervisors to function properly, we need our supervisors to know how to start our application. So we're going to use, and because we want our application to actually be an application, we'll use the application behavior. Okay, and is it start or start link? Start, great. We're going to ignore those first, it's good. Start by default passes 2 arguments in versus the type that's an atom, and the second are the arguments for that, for the application to run. We could pass in the port if we wanted to. I'm just going to ignore those because we've already hard-coded the port. No biggie. All right, so in order for us to define how our application is going to start, we're going to need to tell it that we have a router that we want to run. We'll use the worker function. The worker function comes from the supervisor spec import that I just imported. Before I mentioned use takes in behavior and applies it to a module. Import just says, hey, I want to make sure that this thing is imported so these library functions are available to me. So here we're going to say that we have our first app router and it takes no arguments to start. And then we're also going to provide some options, and the options that we are strategy. That's how you spell strategy, right? Yeah. We're also going to pass some options to our supervisor so that if we can define how the application, how the router gets restarted. So for instance, if we 1-for-1 says, hey, if the router actually dies, I just want to restart the router. But let's say that you have 10,000 processes that are being started. Do you want to restart every single one? That would be one for many. Or if you have every single one that gets killed for, let's say that your OS explodes and says, I can't handle that, and it kills off, it's trying to kill off some processes to maintain, to regain stability. We can say that we want to only restart the, we only want to restart the first main module so that any new requests that come in the case of a web server, any new requests that come in, just dump all those and the user will just have to reload those. Let's also go ahead and pass a name here. We'll call this first app.supervisor. Great, and now we can use the supervisor and we'll start link and we'll pass the children and the options. Oh, damn it, guys. Okay, awesome, thank you. I don't know who said that, but thank you. Okay, great. So let's go ahead and start this guy off. We'll do the same thing that we did before with loading up the mix function using interactive Elixir, and let's go ahead and say, did I call it supervisor? I don't even remember. I literally just typed that. No, okay. First app, start, link. Or did I just call it start? Just start. And we'll pass, doesn't matter what the options are. Ah. Did I? Whoops. First app router. Good call. If I had candy, I would totally throw it in that direction. This side, you really gotta pick it up. Okay. Let's reload that. And now let's go ahead and start this. What am I missing? What's that? Def module, did I spell it all right? Yeah. Yep, that's right. First step, supervisor start link. Alright. Let's do this. That was the same thing. kill this and recompile. I don't get it. So there we go. So now our application, is up and running again. And if we rehit the localhost 4000 with the GET request, which the catch-all router is catching, we'll see it's working. And also, one thing I did forget to say, one thing that we do get with plug is we get not matches just one function that we get in plug. Another function we get in plug is, say, get, and then we pass the route that we want to hit. And then we'll do the same thing where we send a response, send response 200, go somewhere else. Okay, and let's also set this as set rest content type to application JSON, just for fun. So now, what do we need to do in order to see our new request in here? Well, yeah. Nice. Okay, so now if we go ahead and record, did I say hello world? Is that it? That request is not hitting. Let's see, hello. Oh, right. Okay, so I mentioned before we have this really awesome thing called observer in Elixir. So let's go ahead and use the observer. This comes from Erlang. And the observer will give us an overview of all sorts of things, really awesome things. The ones that I'll use the most is this applications tab here and all the processes, so you can see exactly what processes are running, what is dependent on what. So for instance, I know it's really small, and I'm sorry, get better glasses or binoculars, but we can see what is dependent upon what in here. So for instance, this plug, I don't think I can't boot that up any higher. We can see, remember before I was describing Ranch? What Ranch does is what it actually does is it starts up 100 acceptors, and it will farm off the request to one of those acceptors. Excuse me. And we can see Ranch is dependent upon the Ranch supervisor, which is dependent upon some anonymous module getting started, which is also dependent upon a server called ranch_server. I think this is so neat. And because then you can go along and you can start killing things and watch them all reload. So let's go do that. Let's go kill one of these guys. All right, I know you can't see it, but that just re-updated. And it started another function. This was PID 230. So if we kill PID 230, we'll do the same thing. Then PID 231 is the only one that's running, but all the way at the bottom, oh, I should have scrolled all the way at the bottom. But you can see at the bottom, Ranch spun off 605 and 623 as new processes because the supervisor was saying, uh-oh, I lost one. I need to start a new one. Okay, I'm kind of lazy. I think I try to be the best software developer I can, and I think all my favorite software developers are the laziest people that I know. So the reason why I think that is really important to be lazy is so that you don't have to necessarily keep typing the same things over and over and get carpal tunnel earlier than you would. So I don't actually particularly like starting my application from IEX. Instead, let's go to our mix.exs file, and we'll say that we have a module that we want to run called first app. And so now anytime I start IEX, we'll kill that again. Anytime I start IEX, that's going to kick off, oh, I guess it's not set content type. That's why it was exploding. I don't remember what it is a second. So I'm just going to delete that file, or delete that line. Now, instead of me needing to type first app start, it's going to compile it and run it for me. So if we go and hit, we reload our web page, we'll see that it's already started and I don't have to do anything. Now the only thing I have to do as I'm developing my application is just reload that module every time. And because there's really awesome lazy software developers who support open source, there are modules that will reload a module every single time you update that file on disk. So you don't even have to go to IEX if you use something like that. Yay, laziness. Yeah. Ah, good. I did not put that in these slides. So I'm glad you asked. So you go to hexdocs.pm, and hexdocs will give you a list of all those. So let's see what a restarter. That's what it suggests. All right, a restarter. And look at that. This documentation looks familiar, doesn't it? So we could use restarter. We could go, if we wanted to use this, we could go and do mix hex.local restarter. Add this as a dependency. Oops, it's info. Let's go ahead and add this as a dependency. And we'll say we only want to use it in dev. And remember how to get all the dependencies? Yeah, man, mix is the answer. Any question I ask is like, just answer with mix, and you'll be like, yeah, you're right. Or I'll be like, yeah, you're right, because mix is everywhere. Okay. Yes, there is. So I don't have that offhand, and I forget the syntax. That is a Google search away. Okay. Yes. Yes, all the tests that you'll write in your documentation are unit tests. You can write integration tests. It depends what you're doing. Because we're writing a backend, I think unit tests make more sense than integration tests, and integration tests on your front end matter more, in my opinion. But you can write integration tests in Elixir. You can also write, I forgot what it's called. It's like a middle test where you have it's like a unit test and an integration test combined into one. I don't really use that very often. I really just write testing. I really just write unit tests for my backends. Right, so here. Yeah, I'm not going to do that right this second. Oh, well, okay, well, that's pretty easy. You, in order to write your documentation as a test, you say that your documentation is a test by using the keyword doc test, as long as you're using xunit, which is built into Elixir. Xunit, exunit. Okay. Did that answer your question without me getting too deep into the weeds with it? I have another talk in a few hours. After that talk, I'd be more than happy to go and build a demo and put it up on GitHub for you if you want. Actually, I'll do that for everyone because I'm that cool. I don't even get a clap for that. I get a chuckle. Okay. I cracked myself up. It's a good thing that I don't have any screws on my neck, otherwise it'd fall out because I keep chuckling so much. All right, so that's not really a real application, right? Like we're not talking to a database, we're not dealing with WebSockets, we're not dealing with templating, we're not dealing with authentication, we're not doing anything with our front end. We don't even have a real JSON endpoint, even though, or just because I forgot the keyword and I don't feel like looking it up the second. We don't even have an application endpoint that we can go and write a front end to go request. So instead of us needing to use just Mix itself to create our own application, what we can do is we can use a framework. A framework like Phoenix exists for this purpose. If you are following along, is anybody actually following along? Can I stop saying that? Because I don't think anybody has their keyboards out. Okay, I will stop. Anybody have their keyboard out? So Phoenix is awesome. Phoenix is kind of like the Ruby on Rails for what Ruby on Rails for Ruby is kind of what Phoenix is for Elixir. We just walked through how to build our own web server and web handlers without needing any framework in the middle. We would do the same thing if we were doing something like Sinatra and Ruby, if you're familiar with that. Because you now know what the web server itself actually works, there is no magic in Phoenix. Phoenix is doing the exact same thing that we're just doing. We're using plugs. We're using dispatch. It uses Elixir templating. It's pretty awesome. Phoenix itself makes building web applications and specifically smart web applications super fast and super easy. So let's go ahead and create a new Phoenix project just to go and see what that looks like. We'll use, guess what? Mix again to create a new Phoenix application that let's just call Phoenix app. What this is going to do is it's going to create a whole bunch of boilerplates. It's going to tell it, the boilerplate includes JavaScript and that type of thing. So it's going to not only install our Elixir dependencies, it's also going to install our front-end dependencies. So if you really like React, it will, you can use React and Phoenix together. If you really like Angular or you just like vanilla JavaScript, you can tell it, I don't want any of that. Because it's based on, I wish it would go faster because I want to move on. 5, 4, 3, 2, okay. We'll move on. Because Phoenix is dependent upon a database, we'll need to create a database. We'll use a library wrapper called Ecto. Ecto is so neat. While we're waiting for this, if you're ever really interested in some really awesome if you're ever really interested in some awesome Elixir, check out the Ecto hex docs. It's just super fancy. Ecto is a wrapper that allows us to write pretty performant SQL queries, and it deals with migrations, and it deals with types, and it allows us, there's a lot of really awesome things that Ecto allows and gives us out of the box for free. It's super rad. All right, so let's go to our Phoenix app. Let's create our database, do.create, and we'll go ahead and start our Phoenix server. And this is running at port 4000. Reload that, hooray. I didn't really do anything, but Phoenix did it all. It's a responsive web application. I think that's neat. Anytime I see a responsive web application, I have to like up and down my font size because I think they're really cool. Okay. Okay, so what? Why even check out Elixir in the first place? Well, I believe it might come as a surprise to you that Elixir is the next Ruby. Elixir itself is super fast, it's performant, it's fun, the community is awesome. I helped co-found a thing called Elixir Bridge, where we teach, we have open source curriculum. It's up on GitHub if you want to see it, or elixir.bridgefoundry.org. You can just look for Elixir Bridge. So I like to think that I'm part of that growing community. The community itself is growing. You can see Hexdocs has lots of packages available for us, and Elixir makes it really easy to publish our own documentation. And because it's built on Erlang, which has been in production at a telco for decades, it's stable, and I think it's ready. I think Elixir itself is ready for companies to start using it. So before we finish and I take any questions, why would you not use Elixir? Is always a question I feel like I need to answer. Well, the community itself are smaller than a lot of other ones. Java community is ginormous. Python, C, it's really easy to find a Python developer, and it's not so easy to find an Elixir developer. Functional languages themselves can be challenging. We're really taught object-oriented is the way to go from day one, especially for beginners. And deployment isn't super straightforward, although Docker and Distillery make that really awesome. And if you're already working in another language, that's like a reason to say, I don't really want to introduce another language into my production application. However, I would say that the community is growing. Like I said, Elixir Bridge exists. The amount of activity that is going on in the community is increasing. Functional languages, in my opinion, lead to stronger, more testable code. Deployment is getting better, faster, and easier. Distillery. I felt good getting that one out. Distillery is making it really easy. Also, Docker is making it super easy. You take your Docker image, you deploy your Elixir application into Docker, and then ship that Docker container somewhere, like the Docker Cloud, for instance, and all of a sudden you have an application. Now does the same thing. Google Cloud allows us to do that. Beanstalk from AWS allows us to ship Docker containers as applications. And I also think that Elixir small services make a difference. If you are, rather than staying with Java, if you're writing just a small service, try Elixir. Oh, okay, so I just got the big I should stop sign. There's a lot of companies who are using this in production. Most notably, WhatsApp is using it. It's using Erlang and Elixir, and there's a whole bunch of others. So why not try it? Any questions? Or claps? That works too. Great. Thanks.